So this is, I'm going to use a older assignment that I've given in previous years to try and explain to you again how to handle the different kinds of reactions. So in this case, if you look at this equation, we've got aluminum chloride, so that'd be AlCl, let's try that again, AlCl3, and we have aqueous silver nitrate. You can ignore the states for right now, so that silver nitrate is AgNO3. Now I'm going to assume that you know how to write the formulas. Remember, this is plus 3, minus 1, plus 1, minus 1. If you need help on writing formulas, there's a video explanation on the General Chemistry website at the top of the page. Now, this, if you look at this, you recognize this is a compound and that's a compound. So compound and compound makes compound and compound. This particular reaction will be double replacement. In double replacement, they change partners. So the aluminum goes over here where the silver was, and the silver goes where the aluminum was. So you're going to have aluminum pairing up with nitrate. Remember that in double replacement and in single replacement reactions, generally, the subscripts carry over if they're part of a polyatomic ion. So this is a polyatomic ion, so that 3 carries. But this is not, so that 3 does not carry. All right, so then the other combination would be silver and chlorine. So once again, this 3 carried because it's part of a polyatomic ion. The 3 on the chlorine did not carry because chlorine is not a polyatomic ion. All right, so this is a plus 3 charge. This is a minus 1 charge. Now I'm on step 2. Remember, there are 3 steps. Combos, we just did those. Then formulas. And then balance. All right, so this is a 3 and that's a 1, so I'm going to need 3 nitrates. And it kind of looks like we have 3 nitrates, but of course that 3 is part of the nitrate. So that doesn't count for being 3 nitrates, that's just part of 1 nitrate. So in order to have 3 nitrates, what you're going to have to do is do this and put a 3 outside. Now this is a plus 1, that's a minus 1, so they're even already. So now we need to balance the equation. That's step 2, formulas. Now step 3, balance. So in balancing the equation, you can look over here and see you got 3 Cl's, and I'm just kind of starting wherever they look uneven, so that's uneven, so we put a 3 in front of that. That has the side effect of making 3 silvers, so over here you're going to have to put a 3. Alright, and that has a side effect of making 3 NO3s. And once again, 3 NO3s. That's a group, and you've got a 3 in front. But if you look over here, you've got 3 NO3s, so the thing is balanced. Alright, for the next couple, I'm going to just talk to you about types of reactions. So this one looks like, it says solid nickel 3 carbonate is heated. You recognize that's a compound? But it's only one thing. That is one substance. It's a compound, nickel 3 carbonate. Down here, you recognize you got a single element aluminum and a compound zinc chloride. Here you've got a single element chlorine and a compound potassium iodide. All right, so this one, since it's one thing and it's heating it, you're going to turn into something else. That would be one thing decomposing into 2 things. So this, remember, decomposition is one thing. Oops, I don't know if I can do this or not. I can't write on this one. So decomposition is one thing turning into 2. Synthesis is 2 things turning into 1. So decomposing, one thing turning into 2, or maybe more than 2, but at least 2. And synthesis is 2 or more things turning into 1. So if you look at actually writing the equation, nickel 3 carbonate, nickel carbonate, there's your symbols. This is a plus 3 charge, and so that's plus 3. This is minus 2, so you're going to have 2 of these and 3 of those to make the formula right. Now that's going to decompose, pardon my emails here, and reminders. Alright, so that's going to decompose, and the carbonates that say make metallic oxides and carbon dioxide. So on this side you'd put a metallic oxide, which is the metal here, nickel, carbon, or oxygen. Hoping you said nickel. So nickel, and then oxide, O. And then carbon dioxide, what's di mean? 2. All right, so now we got to write our formula correctly, so we're going to assume the charge stays the same. So we have a plus 3 and a minus 2. Common multiple 6, so you have to have how many of the nickels? 2. That's a 2. And then 3. All right, that was second step, formulas. Now balance, third step. You got 1 C. Over here, how many C's do you see? Looks to me like there are 3, because the 3 here applies to everything that's in the parentheses. So you put a 3 right here. How many O's are on this side? Looks like 3 times 3. 3 groups of 3 is 9. On this side, 3 times 2 is 6, plus 3 is 9. So they're even. And then 2 nickels and 2 nickels, so that one's finished. All right, these two are both single replacements because they have an element and a compound. This sentence says, if the single element can form a cation, it replaces a cation, and if the single element can form an anion, it replaces an anion. So aluminum is a metal. Metals lose electrons. They make positive ions, which are called cations. So since the aluminum forms a cation, it will replace the positive part of this compound. Okay, so you'd say aluminum plus zinc chloride. The aluminum goes where the zinc is. Since aluminum forms a cation, it replaces the cation. So you end up with aluminum chloride plus zinc. Now, did you notice when I said aluminum chloride, I just automatically went boom, boom, boom. But if you're doing it, you're probably going to write AlCl. That's plus 3. That's minus 1. So you'd have 3 chlorines to go with the aluminum. Then to balance it, since there are two chlorines here and 3 over here, you'd put a 2 there and a 3 here to make the chlorines even. But that gives you 2 aluminums. So you put a 2 here. And when you put the 3 there, that gave you 3 zinc. So you had to put a 3 over here. Okay, down here you got chlorine. Now chlorine is a non-metal, and non-metals react by gaining electrons, so that would normally form an anion. So it would replace the anion part of potassium iodide. But what is the anion part of potassium iodide? Well, it's the iodine. And you may remember that we actually did this lab where we had the purple layer. This would create a purple layer because the chlorine kicks out the iodine. Iodine's purple as an element, so it would turn the top layer purple, and the KCl would be in solution. All right, so did you notice I put the 2 here and here? Because iodine and chlorine are both part of Brinkelhoff. All right, is this equation balanced? Now, we better check our formulas, I guess. That's plus 1, that's minus 1, plus 1, minus 1. So those formulas are good. So it's not quite balanced. If you put a 2 there, that would accommodate these 2 Cl's. That, of course, gave you 2 K's, so you put a 2 over here. But then that gives you 2 I's. Oh, but you have 2 I's, so you're good. Okay, this one is a double replacement. This one is, you're starting with one thing, so it's going to be decomp. You're starting with one thing, that would be decomp. You're starting with one thing, so that'd be decomp. Okay, this one, aluminum oxide's added to water, that's a synthesis. So let's take a look at this one. We know that it's 2 compounds. Let me write the formula for aluminum oxide. And it kind of looks like a double replacement because compound plus compound. But if they change partners, be sure you catch this. If they change partners, where that goes there and that goes here, wouldn't you end up with the same things? It'd be Al and O and H and O. So nothing would have changed. So this must be a synthesis. So it is a non-metal oxide. No, I take it back. It is a water plus a non-metal oxide. So here's a, no, I said that wrong, darn it. This is a metal oxide and water, because aluminum is a metal. That was my fault. So aluminum's a metal, so we have a metal oxide plus water. And it tells you that it makes a metal hydroxide. So you'd put AlOH, like that, metal hydroxide. Charge on aluminum, plus 3. Charge on hydroxide, minus 1. So parentheses and a 3. All right, so once again, how do you know? You know it's either, based on what we see here, this is compound and compound, so it's either going to be double replacement or one of the synthesis. Since double replacement would give you ALO and HO, if they traded partners and you end up with the same thing, then it must be synthesis. So you look for the synthesis that matches. Metal oxide plus water matches. All right, is this balanced? No, but you see there are two ALs here, so you know you're going to have a 2 over here. That actually changed us so that we have 6 H's. See, there's 3 H's times 2. So I'm going to put a 3 here. And that gives us 3 oxygens, and then 3 oxygens, so that's 6. And there are 3 oxygens here times 2 is 6. All right, these down here are a little bit trickier. And I didn't, on your homework, I don't think you have, I think you might have this one or something similar to this. Let's just run through this one. So you got dinitrogen trioxide bubbled through water. Again, it looks kind of like double replacement because there are 2 compounds, but if they trade partners, you end up with the same thing. So it's not double replacement, it's synthesis. And this one is a non-metal oxide plus water. It says that it makes an acid. So you put an H here, and then you're going to have an N and an O. Now here's the tricky part. We're going to assume that the N does not change its charge. So on this side, you should be able to tell me, I'll run through it. So oxygen is -2 times 3 is -6, so that's +6, and then it's 2 of them, so each one is +3. That means that the nitrogen is +3. So this is +3. I'm going to put a parentheses around this. You don't really need parentheses in your final formula, but I'll put them in here right now to make a point. All right, so if this is 3 and the oxygen is -2, we know that the charge on the NO ion is -1. And we know that because if you look at your periodic table at the bottom where the polyatomic ions are, you will find an NO3 and an NO2. So our task becomes we need to find out which one it is. Is it NO3 or is it NO2 right here? So is that a 3 or is that a 2? The way you tell is like this. For polyatomic ions, so everything down at the bottom, the charges on the individual elements need to add up to equal the charge on the ion. Let me say that again. For polyatomic ions, like this one over here, the charge on the elements has to add up to equal the charge on the ion. So since, for example, in iodate, the charge is -1, oxygen's -2, and there are 3 of them, that makes -6, so we know that -6 plus 5 has to equal -1. So the iodine would be +5. Up here, oxygen's -2 times 4 is -8, so -8 plus something equals -1. This something would have to be 7, so the manganese is +7 here. So over here we know the charges on both of them. We know the -1, so we're going to have to manage the oxygen so that I can get the charge to equal -1. So what if I said 3 plus x equals -1, you would be able to tell me that x is what? It would have to be -4, wouldn't it? So how many oxygen atoms would it take to make -4? I'm thinking 2. So HNO2 is your formula. All right, now we're ready to balance the equation. So there are 2 N's and there's 1 N, so you put a 2 here. 2 H's done. All right, I think I'm going to call that good. I might post a couple of other videos, but this was the most recent and probably the most relevant to what we have done in class. So I've given you an example of single replacement, double replacement, synthesis, and decomposition.